So this is a review for the semester 1 final about chapter 6. Chapter 6 had to do with polynomials. So let's see if you would remember how this would go. Let's say I had something like this. That's a fairly easy one. And that's in factored form, which makes it pretty nice. Can you sketch that for me? I'm going to pause for a moment while you give that a try. Okay, so some thoughts. First of all, because it's factored, I know the roots, also known as the zeros, also known as the x-intercepts. If I set y equal to 0, I get the x-intercepts, right? And so that makes this 3 and this -2. Those are the two biggies. X equals 3 and x equals -2. Those are important spots. Here's 3 and here's -2. Did you call out those spots as important? Good. Then do you remember that one of these is a bounce? Okay. The one that has the multiplicity, that's another word that you need to know, of 2, as opposed to this one has a multiplicity of 1. All right, so if it has a multiplicity of 2, it's bouncing at the -3. So can I just automatically assume, sorry, +3, that it's bouncing this way? No, I got to know whether it's bouncing this way or bouncing this way. It's one of those two ways. So then I really need to know what's the lead coefficient. Well, if I take this and I square it, and this and I put it to the first, and I multiply them together, it's a positive x to the third. Why does that positive matter so much? Because if that lead number is negative, it's going down on the right. If it's positive like this one, it's going up on the right. So now I do know it's bouncing right there and going up on the right. Then, to figure out whether it's going up or down on the left, I look at the total degree. Do you get that if I multiplied this puppy all the way out, it would have degree 3? That's this. That tells me that, 3 is odd number, and therefore they're going different directions, which is the more odd of way to do things. If you're doing the same, if it was going up on this side, it would be the same as that side, and that same is not odd. Odd is different. So I now know that it's going up on the right because of the lead coefficient being positive. It's down on the left because this is an odd number, and I also know it's bouncing right here. So that should tell me bounces here, doesn't bounce there, goes right through. Now, one last thing. I could know the y-intercept pretty easy because the y-intercept is where? Say it. X equals 0. So I could stick in a 0 here and figure it out. So here's my original. I'm going to get some junk off of this. So I move that aside, clear this away. Here's my original. Okay. If I put in a 0, I get -3 squared, which is 9, times 2 is 18, positive 18. So is this potentially, possibly positive 18? I probably should have made it go up a little higher, but at least it wasn't negative. Okay, so there, I made a sketch. That bring back a few things? Okay, next, let's say it's a little more complicated one. X minus 5 to the third, x plus 1, and an x, and I'm going to throw in a minus right there, and then y equals all that. Now, make a sketch of that. I'm going to pause while you give that a try. Okay, some thoughts. You should have noticed that negative there changes our lead coefficient. The lead coefficient on this guy would be the x, that negative x, and that x, and this one's to the third. So it's going to be x to the third, fourth, fifth, and it's got a negative x to the fifth is my lead coefficient. Why do I care so much? Because it's negative in the front, which means your graph better have ended going down. Raise your hand if yours graph is going down on the right. Okay, good. Question? Okay. Then, the fact that this is odd tells me that the other end must be different. So it must be going up on the left. Then, it has to be hitting a couple spots. This is important. That has to equal 0. Negative x plus 1 has to equal 0. I bet some of you thought differently. You thought -1 was it. It's +1. See me solving this little thing and setting it equal to 0? It equals 0 when x is 1. So that means 1 is this key spot right here. Not -1, but 1. And over here, this is as simple as it looks. You just put in a 5 to make it equal 0, so x equals 5. So 1, 2, 3, 1, 2, 3, 4, 5. There we go. There's the other one. And now, is there any bouncing happening? Well, no bouncing. This is a power of 1. This is a power of 1. That's a power of 3. Do you remember the snake? The power of 3 is the snake. I had a 12-minute warning on the alarm there. Okay. So if I have the snake going at the 5, that's one of these. And it looks like, I'm terrible at these, but that's how it would look if it was going up on the right. Unfortunately, it's not. It's the other way, so I have to really challenge myself. There. I think that's the way a snake should look. And now I'm going to have it cut through at the 1, because this was a power of 1 right here. So then this, as it's heading up, needs to cut through there. And then it would be really helpful if I knew what the Y-intercept was. Then I know if I should like touch here, or if I should touch up here, or where I should touch. So I'm going to go figure out the Y-intercept real quick. The Y-intercept is where x is 0, stick in a 0 here and a 0 there, and I get -5 cubed. And this part right, oh, and a negative, also a 0 right there. Oh, and that's a powerful one, because if I want the Y-intercept, I set x equal to 0. As soon as I put that one in as a 0, it multiplies by everything else, and it becomes 0. So, oh, that's right, because there's another root right there. All right, so it has to hit here. All right, so then I guess as it's heading down through there, because there was not a bounce at 1, then it has to go back up this way, and maybe it just keeps going up. Is it supposed to be going? Yeah, here it is. It's supposed to be going up on the left, so there we go. There's our rough estimate of what this graph should kind of look like. Any questions about that process? Okay, done. Let's move on. Other stuff in Chapter 5. What if I asked you, just from looking at this, what are the roots? That's the same exact question as what are the what? X-intercepts, which would be 0 and, what's that one? 3 and -2. That one's 0, and that's important to know. Some kids get confused by this. What if there was like a 7 out front? Then would it mean that it has a 0? No, because you can't make a 7 0, but it could make a 7x, then it would be a root of 0. All right, so back to my original problem. It was like that. So the x equals 0 was a root, x equals 3 was a root, and x equals -2 is a root. And what is the multiplicity of this guy? 3. What's the multiplicity of this guy? 2. What's the multiplicity of this guy? 1, because there's a little 1 that you don't see right there. Okay. All right, what's the total degree of this? I know it's a mind melt, because you're like, should I add them or should I just like find the biggest one? Because in certain problems you find the biggest one, and in other problems you add them. Well, think of it this way. If you multiplied this puppy all the way out, do you agree you'd have an x to the 3rd and an x squared and an x that would all get multiplied eventually and make an x to the 6th? Then that's the biggest one. So once you've got it all multiplied out, you pick the biggest one. In this, if you said the answer was 3, you would be wrong. The answer is 6. But if it's already all multiplied out, like that, what would the degree of that guy be? Degree 5. You would not add them all together. That's only if it isn't multiplied out. Once it's all multiplied out, you do just pick the biggest one, and that's the degree. Okay. Now, if I asked you on this one, is it going down or up on the right? It's a very simple question. It's going down on the right. So I don't even know how the graph exactly looks, other than it is a parabola and it's going down on the right. So maybe it's something like that. I don't know. It doesn't matter that much to me. But right now, I want to remind you how to write a limit. That's where limits came in, is in this chapter. So how do you write the limit statement for this for the right-hand side? If it's, you all said it's going down on the right, so that's this part. How do I say that with a limit statement? Why don't you give it a shot, write it on your iPad, and I'll tell you how to write the limit for the right side. I'll pause while you try that. Okay, I want to warn you, these are very picky in how you write them. So let me show you, and the reason we're picky about it is because on the calc test that all of you, whether you take HL or whether you take AP Calc, either way you're going to take the AP Calc test, they're going to judge you on limits. And if you write the little X arrow to this in the wrong spot, you will lose the credit. Okay? So the limit of the function as X, notice where I'm writing it, goes to, that must be all contained underneath the limit. If you let that stray over here and say X goes to infinity or whatever, nope, they won't give you the full credit. They'll dock a point for form. The limit's supposed to have the X underneath the lim. I know it's picky, but it's not, I'm not the one being picky here. I'm trying to get you ready for the AP graders who are. Okay, so that's in every, oh, and an equals, that's in every limit statement you will ever write, at least in this course. Then you just have to fill in two things. Actually, I should clarify. Unless you're doing the interior limits, which we'll talk about in a moment. But for right now, actually, I'll just leave the X goes to. That I can safely say. All your limits will say that. Okay. Now, if I want the right side, which is what I asked for, then X is going to infinity. Way to the right, X is getting closer to infinity. And then this, if this is like the X spot, that is like the Y, or the height. So when I go infinitely to the right, is my height going to be down or up? It's going to be down. And infinitely down means negative infinity. Raise your hand if you wrote that one correctly. Okay, good. And if you didn't, just because of that X goes to infinity thing, just get it straightened out now. You can't have this flying all over the place over there. Okay. Next, what about the left side? Well, that one's a pretty easy one. I'm going to give you a different picture. Here's one. This is a function that we haven't talked about much. We'll talk about more in the second semester. It's called the basic logistic function. But it's got an asymptote there, and it's got an asymptote here. And let's say that this is at 10. You can set it anywhere you want to on these functions, but I'm going to make it be 10. I'd like you to tell me the left end limit and the right end limit. I'll pause while you give that a try. All right, you should have said on the left side, the lim of the function as x approaches negative infinity would be, what does it get close to when you go forever that way? Well, it's got an asymptote line. That means it gets closer and closer to the asymptote, which is, I was trying to say, at 0, and I hope you said 0. On the right side, the lim of the function as x approaches positive infinity, that's the right end limit. When I get there, this will get infinitely close to 10. All right, so there's a quick reminder on limits. Next thing, yes?
We never have to do stuff where like third class and stuff, so.
Yes? Yep. All right, so let's talk about that. Let's say you have an asymptote like this. Let's say that you have another asymptote like this. And let's say that your graph goes like this and like that. So there is a strange kind of limit that goes towards the middle. The limit of this one, let's say this is going up to 3, and let's say this is going out to 4 here. The limit of this one as you go way to the right would be 3. The highest it'll get is 3, right? So as we go way to the left, the limit's also 3. But how do you write this area? You say the limit of the function as x isn't approaching infinity. X is approaching 4. This is where 4 is. As x approaches 4. Well, it depends. If you're approaching 4 from this way, it goes up. If you're approaching 4 from this way, it goes down. So You say the limit of the function as x approaches 4 depends on whether you're coming from x's that are negative, that would be this way, you're coming from where x's were negative, then it's going to infinity. For this area right here, you'd say the limit of the function as x approaches 4 from where the x's are positive, that's over here where x's were positive, you're approaching from over here, you're coming this way, is negative infinity. Now, I know that's a bit of a mind bender, but yeah, you could be responsible for seeing something like that. All right, then there's one more topic I got to get through in a very short amount of time, and that is just if I give you one of its zeros, if I gave you x to the 4th minus 3x to the 3rd minus x minus 1, and I said it's got a 0 of 2. Do you remember how to do this? 1, negative 3, negative 1, negative 1. Draw the line, drop it like it's hot. Take Snoop Dogg's advice. Remember this? This is called synthetic division. Okay, and then you go this times this. 1 times 2 is 2. Add these, negative 1. Multiply these, negative 2. Add those, negative 3. Multiply these, negative 6. And I'm going to cheat and make this a plus 6. I know. I just cheated, but that's okay. Because now it's going to work out, and it's going to have a 0 at the end. That's your sign that it factored properly. And the answer would be, this is the x, and this is the x squared, and this would be x minus 2 for that. And then this is the other part of it. That's how to factor using synthetic. So that's all actually, I'm going to pause for a second, see if there's any more I want to add. Yeah, I decided that is all that we are going to do for that chapter. That pretty much covers all of it.